Hi, welcome to our channel True Up. According to recent news, the United States has ceased giving the new technology, 5 nanometers extreme ultraviolet lithography machine to China for future research and development. Indeed, China has made substantial technological advances as a result of its reform and open policy. Unfortunately, China's exceptional advances in technology have piqued the US's interest. As a result, China must develop its own method to become immersed in technological breakthroughs. A sequence of hard effort and perseverance by Chinese researchers has effectively demonstrated to the world how great China is in terms of courage and might. As a result, the United States felt threatened once more and decided to cease supplying China a 5 nanometers extreme ultraviolet lithography equipment. Indeed, China has not yet mastered the most recent technological talent in the semiconductor business, prompting China to constantly strive to fix this problem. A few years ago, China was anxious to acquire an extreme ultraviolet lithography equipment from the Netherlands, but it did not work out due to US opposition. What exactly is an ultraviolet lithography machine? Because we plan to purchase extreme ultraviolet lithography machines from other nations, it is sufficient to demonstrate the importance of this type of equipment. In reality, the lithography machine is a critical piece of chip fabrication equipment. It is classified as a lithography machine for chip production, a lithography machine for packaging, and a projection lithography machine for LED manufacture. The lithography machine used to create chips is one example of a deficiency in China's semiconductor equipment production. The high-end lithography equipment needed by China's chip manufacturing plants are entirely imported, and many businesses will purchase lithography machines from the Netherlands for chip manufacture. In terms of high-end lithography machines, Nikon and Canon, in addition to prominent businesses ASML, have manufactured lithography machines, and Nikon has received orders from Intel. However, Nikon, which was formerly able to compete with ASML in the high-end lithography sector, has recently fallen far behind. Even if Nikon significantly reduces the price of the lithography machines it offers, it will be impossible to change the situation. Why is this the case? On the one hand, after entering office, Intel's new CEO will not renew the deal with Nikon, causing Nikon to lose a big customer. On the other side, it is tied to Nikon's lack of technological strength. Nikon's lithography machine has several problems as compared to ASML, such as operating system architecture, etc. Furthermore, its real performance falls well short of the official hype. It is difficult for TSMC, Intel, Samsung, GlobalFoundries, and other big chip manufacturers to purchase such substandard goods in order to save a few dollars. Nikon currently behind ASML in this category of high-end lithography equipment. Only a few vintage Nikon or Canon low-level lithography machines remain in use in the mainstream semiconductor manufacturing line, with the remainder being ASML lithography equipment. Nikon's lithography machine can only conquer the market in this instance by offering ultra-low costs. According to statistics, ASML's NXE3350B extreme ultraviolet lithography equipment costs more than $100 million, whereas ARF immersion costs over $70 million. Nikon lithography equipment, on the other hand, cost one-third the price of ASML. The EUV lithography machine is another name for the extreme ultraviolet lithography machine. The technique will employ EUV light with a wavelength of only 13.5 nanometers. It can etch delicate circuit designs with an exposure plate pitch of less than 20 nanometers, something that ordinary photolithography equipment cannot do. A range of element technologies, including as light sources, optical devices, masks, photoresists, and lithography tools, are required in the process of bringing the extreme UV lithography machine into real use. The generation of a strong EUV beam with a very small wavelength of 13.5 nanometers is the most difficult of these component technologies. This EUV beam may be created from high-temperature and high-density plasma, which can be formed in two ways: laser-generated plasma, which is generated by concentrating a powerful laser beam on a specific material, and discharge-generated plasma, which is generated by pulsing high current. The condenser collects the EUV beam generated by the plasma, which subsequently falls on the mask. Finally, the projection optics expose the EUV beam reflected by the mask to generate a pattern on the photoresist deposited on the wafer surface. Today, EUV lithography technology is still under research, but it is projected to be in use within a few years. The needed output power for mass manufacturing is 350 W or more. However, the current output power of EUV light sources in production is around 100 W, which is still quite low. The United States is preventing China from purchasing intense UV lithography machines. China has expressed interest in purchasing an extreme ultraviolet lithography equipment from ASML in the Netherlands as early as 2018. This lithography equipment weighs 180 tons and is valued at $150 million. However, we have not received the items as of yet. The cause is the United States obstruction. China's current ambition is to mass-produce extreme UV lithography equipment and have them operational by 2030. In reality, the lithography machine cannot be summed up simply with prefixes like 5 nanometers and 7 nanometers. The development of lithography machine has gone through 5 stages so far, divided according to the light source, and the lithography machine in the 4th stage is divided into 2 types, namely the 4th generation stepper projection lithography machine and the 4th generation immersion projection lithography machine. The immersion projection lithography machine of the 4th generation is more sophisticated than the step-by-step projection lithography machine of the 4th generation. Only throughout the manufacturing process can the 4th generation step-by-step projection lithography machine precisely establish the process node of the manufacturing chip to 65 nanometers, and the 4th generation immersion projection lithography equipment can go much smaller, reaching 7 nanometers. Lin Benjian of TSMC proposed adding a millimeter of water to the photoresist, which allows the wavelength of 193 nanometers to be adjusted to 134 nanometers by refraction. The 4th generation immersion projection lithography equipment is capable of producing both 28 nanometers and 7 nanometers devices. According to the naming standard indicated above, we may claim it is either a 28 nanometers or a 7 nanometers lithography machine, therefore this statement is not entirely correct. The technology in the extreme ultraviolet lithography equipment that our government wishes to purchase can raise the limit to 1 nanometer. If we have such technology, we will be able to compete with the best in the world before the lithography machine's total technical level exceeds this limit. However, China has only mastered the technology of the 4th generation stepper projection lithography machine at the moment, and the 4th generation immersion projection lithography machine is only in the demonstration stage of mass production. Thanks for watching our video. We would appreciate it if you subscribed our channel and gave us a thumb. See you.